Welcome to Study Loop.
This is the answer to Chapter 13, problem number 37 from the Smith Organic Chemistry textbook. And this problem says, like alcohols, ethers undergo alpha cleavage by breaking a carbon-carbon bond between an alkyl group and the carbon bonded to the ether oxygen atom. And so with this in mind, propose structures for the fragments formed by alpha cleavage of this ether that I've drawn here, and suggest a reason why an ether fragments by alpha cleavage. Okay, and so alpha cleavage means that the two bonds that we're going to look at potentially fragmenting or cleaving are this bond here that I will draw a line through in red, and this bond here that I've drawn a line through in green. And so we'll take these one at a time. So if we were to cleave the red-lined bond, so the red arrow corresponds to the red-lined bond, so we would end up with two pieces. So we would get this piece, and this piece is going to be our radical piece. So there's a radical there on that carbon. And then our other piece is going to be the carbocation piece. So CH2, O, CH2, CH3. Okay, and there's a carbocation here. And so right now we can address the end of the problem. So the reason that an ether is going to fragment by alpha cleavage is this. So a lone pair from the oxygen there can add in, and so we have a potential resonance structure that's going to look like this. So CH2 now double bound to this oxygen. The rest of the molecule is the same. And so the positive charge is now seated on this oxygen, which is an electronegative atom. So that's good. We like to seat charges on electronegative atoms. And so this is a resonance stabilized carbocation. So it's a more stable fragment. And so that's why ethers are going to fragment by alpha cleavage, because they form resonance stabilized carbocations. And so the same is going to be true if we cut the green bond, cleave the green-lined bond. So in that instance, we'll get this methyl radical. So there's our radical. And then we will again get the rest of the molecule. So that's going to look like this. With the carbocation located there. And then again, we can conceive of a resonance structure where, again, it's going to be a matter of an oxygen lone pair adding in. And so there we go. And now, once again, this positive charge is going to be seated on that oxygen. And that's good. That's what we like to see. Charges on electronegative charges on electronegative atoms. Yeah, and so there we go. There's the two fragments. We've discussed why an ether might fragment by alpha cleavage. It's because it's going to form resonance stabilized carbocations. And so that's the answer to chapter 13, problem number 37.